This is a question from your textbook. We're told a force of 4I plus 6J acts on a particle of mass 2 kilograms. The particle is initially at rest, so t equals 0, v equals 0, at the point with position vector 0I plus 0J. Find the acceleration of the particle. So, we are told that the force, that is R, is equal to 4I plus 6J. We know R equals mass times acceleration. We were told the mass was 2, so we've now got R equals mass times acceleration, which is 4I plus 6J equals 2A. I have divided through by 2, so the acceleration vector is equal to 2I plus 3J. The next part says find the velocity of the particle at time t. So we know that vector A, acceleration, is equal to the derivative of velocity, the derivative of the velocity vector with respect to time. So we know that the derivative of the velocity vector with respect to time is equal to 2I plus 3J. Anti-differentiating these, we get the velocity vector equals 2t in the I direction plus 3t in the j direction plus the constant vector. Now we know when time is 0 and velocity is 0, we are told that the position vector is 0I plus 0j. We know when t equals 0, v equals 0. So substituting that into our formula there, we get the constant vector is equal to 0. So we now know what velocity is. Part C asks us to find a position. So we know the position is the derivative of the velocity with respect to time. We're now asked to find position in terms of time. We know velocity is the derivative of position with respect to time. So what we can do is we can say, well, we're looking for the position vector, which we normally call r instead of x. So the derivative of position vector with respect to time is equal to the velocity vector. Anti-differentiating both sides with respect to time, the antiderivative of 2t is t squared, antiderivative of 3t is 3 on 2 t squared, and we've got our constant vector. This time we know when time is 0, we're told the position vector is 0I plus 0j, so we can find d. That gives us the position vector is t squared in the direction of unit vector I plus 3 on 2 t squared in the direction of unit vector j. The last part asks us to find the Cartesian equation of the path. To do that, we know that x must equal t squared, and we know y must equal 3 on 2 t squared. So, because they both have t squared, we can substitute x into where t squared was. When we do that, we get 3 on 2x, not 3 on 2x squared. So y equals 3 on 2x